Here's our ball drop project. These are the instructions for completing it. We're to take a ball, drop it from a known height, and record the height of the rebounds. Then we were to record enough of those rebounds to come up with a sequence. Once we found that sequence, we were to calculate the limit of that sum. So, and then in the end, we're going to determine what the total distance, what is the total distance that the ball will travel. So here's my my project uploaded into the software I used to calculate or take measurements. This is 60 inches. I measured this from the baseboard to a line on the whiteboard, and we measured that with measuring tape. That's our reference point. This is my first point, the height that I dropped the ball as it bounced, and each subsequent point thereafter. As you notice, as you go along the list, the ball is bouncing not as high as the previous one in each time, which is kind of obvious. We've all had a ball that we've thrown down and bounced before, and you notice that little by little it decreases. Well, the kind of idea for this is to determine how much it's decreasing by, and if there is some sort of a method or a way to calculate that, and I'll show you that there actually is in just a second. So I took all of my measurements here, I compiled them in a list. Let's see, here's this list right here, and from my first measurement on down to my last measurement. This is the difference in inches from one measurement to the next. First one's 11.3, next one is 9.6, 7.34, and so on. And this is the percent difference of each one of these intervals here. Okay, and what I did just to kind of calculate the difference here is I took all the measurements and I added them up, all 12 of these. I added them and divided by 12, and it gave me a 0.8 average. 0.8. So 0.8 is the difference each time the ball bounces. It only rebounds 0.8% as high as the previous height. So I used those numbers, and I determined my AN, and just to kind of give you a short little breakdown here, my original height was 59 inches. My first rebound was 59 times 0.8, which was 47.2. And if I follow this exactly, multiplying it by 0.8, you'll notice that for my previous measurements, that one, the actual measurement was about 47.67. The second rebound was 38 inches. Now, if you notice here, my first was 47.2. My second was 37.6. Very, very close to what I actually measured. So this is a really good estimation of the project or the rebounds. If you notice here, my second rebound is also 59 times 0.8, which is exactly up here, H1 times 0.8. Another way I can write that's 59, my original height, times 0.8 squared. My third rebound was H3. It is 59 times 0.8 to the third, which is 30.28. And if you notice here, each rebound is also the number that I'll use to square or cube, or the power that I'll multiply my ratio 0.8 by. And again, this is a ratio that it's changing each time by 0.8. So this would continue on all the way down to my 12th measurement. This is how I calculated my AN. My AN is basically my original height times R, which is a ratio, to the nth. And this nth is going to be whatever n that my A is. So if it's H5, then I'm going to have 59 times 0.8 to the fifth. So now here's a way that you can calculate and this only works if your AN, your R is less than 0.1. If your, is less than 1. If your R ratio number is greater than 1, this formula that we're going to use, a over 1 minus r, will not work in order to calculate an estimated limit. Very simple way to do this. If you don't have a calculator or anything that can assist you, you just substitute these numbers in, and you wind up with 295. And this basically is this is taking your limit of your AN, and you plug it or substituting into this formula to determine what the total your limit would be. And in this case, it's 295. And here's another way that I'm going to show you how that's calculated. I used Wolfram Alpha, and I just substituted these numbers in. It's a geometric sequence, if you haven't already noticed that. This is 59 inches, my original height, times 0.8 to the nth. If you were to take that from 0 to infinity, again, you come up with the sum of 295, and that's 295 inches in total. And here's just kind of like a graphical chart. If I were to take my first bounce, ball drop at 59 inches, add the next one, I believe that was 47, we discussed that earlier, that gave us just over 100 if you were to add those two. The next bounce after that, I believe, was 37 more. That added to the previous 2 bounces gave us nearly 150, and so on. Ultimately, as your ball bounces, though, you're going to be adding less and less. If you notice here, I mean, this ball is going to bounce, and eventually it's going to come out here somewhere where it's bouncing and it's almost negligible because you cannot tell. There's really nothing it's adding to. I mean, it might be bouncing a micron for all we know, and so at that point it eventually becomes null. You won't use it. So in the end, that's what the total sum was. It was 295 inches. Okay, and again, the last thing that the project asked was to calculate how far the ball will travel. Now, this is the sum of the separate heights along the way. So that all I did is I took the sum of this height, this height, this height, this height. If you really wanted to get technical about it, the ball does travel quite a bit more than just 295 inches because the ball is dropped 59 inches, but we have to consider that the ball bounces up, and it bounces up 47 inches, but it also drops back down 47 inches. Now, on the third bounce, it bounces up, I believe it's 36 inches, somewhere in there, but it also drops 36 inches. So, except for the first drop, we'll have to multiply each one of these subsequent drops by 2 to determine the total distance traveled by the ball. So in my case, all I did was my limit, the total number of heights added to each other along the way, was 295. I multiplied that by 2, and that gave me 590. But I had to subtract one of the first ball. The first bounce, it didn't bounce to get up to the top, it was already there. So I'm going to subtract 59, my original height, because there was no bounce to come up to the original height. So I'm going to subtract that, and that's going to give me a total of 531. So in all, my ball travels 531 inches if you calculated that out exactly.